Welcome back to Chem 101. In this video, we're continuing our discussion on molecular compounds versus ionic compounds. Now, in the last video, I told you that elements on this side of the periodic table, actually on this side of this line here, are metals, main group metals, transition metals, and then over here we had non-metals. And if we have a non-metal and a metal pairing together, we call that an ionic compound. And if we just have non-metals pairing together, those are molecular compounds. Now, ionic compounds are composed of a cation and an anion. So a positively charged atom and a negatively charged atom. And they connect together. Sodium chloride is an example of that. NaCl. This comes from having a cation pair with an anion. So the plus charge of sodium goes with the minus charge of chlorine. And so the point of this video is to show you that we can actually figure out the charges on a good deal of elements just by their position in the periodic table. So our first column here, everything in this first column will actually form a +1 ion. So sodium is in this first column, so it'll form sodium plus. Lithium would be lithium plus. Hydrogen is H plus. Everything in this first column is +1. Everything in the second column is +2. Now, beryllium 2+, magnesium 2+. What does that mean? It means they're losing electrons. Remember, you can't lose protons. The protons are what defines an element. Hydrogen always has one proton. And since they're all neutral, they all have the same number of electrons as they do protons. So hydrogen normally has one electron. So what you'll notice is that all the metals tend to lose electrons. That's why they're forming these positively charged ions, cations. Our nonmetals are going to be the opposite of that. They tend to gain electrons. So where fluorine, for example, has 9 protons and 9 electrons, it's actually going to gain an electron and be a minus charged ion, or an anion. So fluorine would form F-. And so anything in this row here with fluorine, chlorine, bromine, they all form -1 anions. Everything in this row with oxygen forms a -2. Everything in this row with nitrogen forms a -3. Carbon actually can form a -4 or a +4. Carbon is very special that way. Boron, aluminum, gallium, anything in this row can do +3. So there's a trend here. +1, +2, +3, +4, or -4, -3, -2, -1. These guys don't form ions. And we can actually talk a little bit more about the names of these groups here. We call this whole column the noble gases, mainly because they don't react. These are very unreactive. They don't form ions, they don't gain or lose electrons easily, so they tend to be very stable. All of these other guys that are forming ions, these are reactive, but our most reactives are column 1, column 2, and column 7 here. Now the numbering is a little weird. 1, 2, 3, 4, 5, 6, 7. We tend to skip the transition elements. And I'll have to do another video on the transition metals because they form multiple charges. So for example, copper can have a 2+ or a 3+ or just a 1+ charge. They're not set like these guys are. These guys are always +1. These guys are always +2. So that makes it easy when we're pairing up or when we're writing formulas for ionic compounds, which will be the subject of a later video. So the noble gases here, we call, we call these guys the alkali metals. We call these guys here, the second column, alkaline earth metals. And these guys here in row 7, they're the halogens. So So if you have a halogen lamp, chances are it has fluorine, chlorine, bromine, or iodine gas inside it, so the halogens. So this should help when you're trying to figure out what charge is on your ion or what charge your ion would form. Nitrogen would form a 3-, hydrogen would form a +1, so a nitrogen with 3- would need 3 hydrogens that each come with a plus charge to cancel them out. So this is how we would write the formula for NH3. This is ammonia. And so we can see that with the charges. This would also be a molecular compound because it's composed of, well, hydrogen tends to be classified with the nonmetals. Sometimes you'll see it on the periodic table over here right next to helium. All right, so that's pretty much how you can tell the charges of various ions. In a later video, we'll come back to writing ionic compounds, and I'll show you how we do that, both how to name them, how to draw them, and how to treat transition elements.